Hey everyone, my name's David, and I'll be running through a Calypso Basics workshop today. I'll focus a lot on the basic programming aspects of the Calypso here, which y'all will be working with, but we'll focus a lot on I think navigational aspects more so. So an introduction to Calypso here utilizes a lot of aspects of artificial intelligence (AI) that can be seen throughout our modern day world. It's pretty good for simulating all of those, and I believe many of you will be using this program or a similar one for your projects. So, to get started, artificial intelligence, it can be seen pretty prominently throughout our daily lives for speech, or for hearing, for sight. Uh, AI has all those aspects nowadays, and it's increasingly advancing. So it's important to take a look at those aspects, and see how they can be utilized, which is what we'll be doing here today. So what I have open here right now is the basic Calypso interface. This shows your basic. My apologies. Your basic controls on the left-hand side here, on your keyboard at least. If you're using a controller, which is also possible with this program, it will, I believe, automatically adjust to whatever controls of those might be. We're in the CalypsoRobotics.com. This is the web browser version of controls for Cosmo. And Cosmo's our robot here, by the way, which I will get more into detail on that here in a bit. So you can go online to calypso-robotics.com, what the URL I have here, and you can play around with this, experiment with it. I believe most of you will also be working with a physical robot as well. Many of the aspects on here also translate to that. Just there are some small nuances we will address here. Lots of differences between like the online web browser here and then the real physical robot that you all will have. All right. So controls, left hand side right here. In the middle here, this is I would call like your command lines. This is where all your statements are going to go that make your program essentially run. And then on the right hand side here, we got the menu options. This home button right here, you click that, you'll get all these different options. I'm currently signed into an account. If you don't have an account yet, I believe we'll say something like sign up or whatnot. If you're gonna play around the online version here, I could recommend you make an account. It'll allow you to save things to your profile and load them back in whenever you log back in. So it's pretty useful. Other than that, you got your settings here. If you're gonna play around this app, I believe it starts you off at novice mode. I recommend just switching it to normal mode. This will give you more viable options for what you'll need to do with it. And we don't need to worry right now about the rest of the options. This select character feature. If you click this, you'll see the various objects in the world and the world itself. This has to do with mainly what the map is going to include, which I will show you here in a bit. But what this essentially means is you can code your robot, but sometimes there also might be instances where you have to code your actual cubes, the charger, or add some aspect to the rest of the world itself. And this is the camera viewer. This camera viewer, you can, if you turn it on, I won't turn it on right now because I believe it gets buggy while I'm recording. But essentially, Cosmo has a camera feature built in, and this is part of the facial recognition features that artificial intelligence utilizes nowadays. So, filters for your face, or when you use your camera, or unlocking your phone screen for your face, that's all, AI related. And it can use a similar technology to what Cosmo has implemented into itself. These four buttons right here are fairly important. This is this run program button. So once we have any code, this will automatically run and will take us onto a map view, which we will look into here soon. This is the rule editor view. This will just take you back to the screen. All right. So let's go to the map editor view, which is this button. You'll notice this is like basically your world, your environment of which you'll be coding in. Again, we got the commands for your keyboard on the left-hand side here, top left. And then these are your objects that you can put into your world. These are cubes right here. You see, you hold left click and you drag it out. You can drag out cube 1, cube 2, and cube 3 respectively. If you want to put it back, you just drag it back, to a corner, and it will automatically, be put back into your little object space here. This is a charger, which there are some aspects you can do with Cosmo's own charger. And yeah, this little robot, its name is Cosmo. We will essentially program it to do the tasks we want it to do and experiment with the aspects of artificial intelligence within it. These are shapes. Shapes are like a little identifier for Cosmo, which we will see utilized here today as well. Now, what we have here are wall builds. So if I drag these out, you can see how I can build, a pretty rough environment. And basically, Cosmo is able to see the walls here, and he can navigate a path depending on what his goals are, which you will see here today as well. So I can drag those back in, and those go back in the box. This is the room. If you drag this out, you see you'll get room 1. You can right click to customize it, rename it, and you can do a lot of program a lot of aspects of this as well. This is more like a location or area for Cosmo to go to. And right here, this is a face. Essentially, you can upload your own face in the Cosmo, and then it can recognize you. So you can play around with that too. So we'll go back to our editor view. And this is a state machine view. This is essentially, once we start adding pages, this will stock up, and you'll see some features develop over here too. We can discuss that, and you can look into it at another time. So that's the basic interface that we're working with throughout your project time. By the way, we should understand when you go to the map editor, you can for these cubes, you can edit them, which will be important. You just right click on it, so you can change color, orientation. You can set it as unseen if you don't want it to be seen. Maybe you're testing something and you want to just kind of remove the cubes for the time being without removing other properties. So we'll put that back for now. So start off, we want to review just kind of how you can write a program. So these pluses on the wins and do's are what is how you start making your program. The win condition right here on the left, this is very important. You need to make sure this condition is met for anything to happen over here in the do condition. So for win, let's say we want to have Cosmo see something, which in the most generic case will be a cube. It will be manipulating cubes a lot in your projects, I would think. Cube, and you can describe it, orientation, whether on a frame or even the specific color that is. And the end feature, this is for like if it's in a room. For now, we can just say a cube. We can make it move towards it. This final it specifier is pretty important. You want to make sure you specify the cube as like the object for a Cosmo to move towards. Now, if we go back to our map editor right here, we need to drag out a cube into the world or this environment for the editor to have any of these conditions met. If Cosmo doesn't see a cube at all, then none of this is going to happen. We're going to move towards it, right? So we'll go back to the world and we will run our program. This is very, basic right here. It saw a cube and it moved towards it, and that's all it did. Oh, and up here, this is like its speech recognition or attempting to recognize that speech. It gets very distorted here and there, but it's pretty cool. So once we're done testing, by the way, every time you test your environment, you're gonna have the code on your left, and then you're gonna have the environment on your right, which is pretty handy, I would say. You can also drag more cubes out. You can edit the environment while you're testing. Just keep in mind, I do not believe any of those like changes or anything you drag out it saves. It only saves pre-test. All right. So stop our program for pressing this red square. So to delete lines, you just click on this section you want to delete, and you press the delete key above your whatchamacallit backspace key. If you press backspace, then it's just going to start the program, which is one of its keybinds, either run program. So you want to press the delete key. And same here as well. You just press where you want to delete and go for it. So start. That's the very generic rule or method of programming Cosmo to move towards the block. We want to start with like the actual rules of like the specific program, which is Calypso. Calypso has a couple of laws that dictate its programming, I would say, syntax or its programming methods. So let's say we have Cosmos seeing a cube. We want it to move towards it, right, like so. Now we should realize that cube, is a very generic term. See, because we see here there's cube 1, cube 2, and cube 3. So the Calypso program generally comes with 3 different cubes, as you can see here: cube 1, cube 2, and cube 3. Or you can just specify a cube, which is any cube. And so if you highlight over it, it'll even say any cube. But if you only specify cube 1, it'll only recognize its conditions based on cube 1. Now the differences seen between the cubes are just you can notice the symbol. Cube 1 is like that lightning symbol. Cube 2 is 2 squares. Cube 3 is whatever that pattern is, right? So that's how you tell the differences between those. So back to the topic at hand. When it sees a cube, it'll move towards it, right? Now we can say if it sees a cube, we actually don't need this at all. My apologies, but yeah, we see a cube, we move towards it. Now we want to go to the map editor. So here's one cube. Cosmo, we already tested this, it sees it. Now we want to go, let's say we drag a second cube out here. Now remember I said, this cube is a very generic term. It describes all cubes, included in the Calypso program. So it's going to see both of these. So if we run this program, we know it will go towards that one, right? We can run it again. Still goes towards that one. The reason it's going to be going towards this one is because it's simply closer. This is the first law of Calypso right here, basically. It'll apply to like just generic objects, the same objects. We say when see a cube red. All right, I can specify the color. I'll show you how to do that again. We go to colors here, and you get like this palette. You can say red. Now we gotta go here. We can color both cubes red, right? Right click, change color, red on both of them. Now they're both red, right? It sees 2 red cubes, but it's only gonna move towards this one. It's gonna move towards that one because simply it's closer to it. All right, the distance is less between the two. This will come in handy, during if you have some very similar objects out in the field that you need Calypso to locate. It's just important to also keep in mind when you're making your programs, right? So I will exit that. I will delete this with delete keys. We should review now the second law of Calypso, and there are a total of 5. So we'll just be running through those today, and I'll be doing a demonstration of how all of them. They all apply to the program in the grand scheme of things, right? So let's move on. We shall now discuss the second law of Calypso. Now the second law basically is how the order of your lines won't matter depending on the behavior of it. If some behaviors can't run, essentially it will skip over to what can run, what when condition is met. basically your conditions over here can only, or your lines of code can only run once this one condition is met. So let's say we have when bumped a cube, we wanted to grab it. And by the way, this and then statement just allows it to progress for progress to the next line. You'll see this on some options that comes with the do statements that you write. All right. So we can then say below it, when you see a cube, you can move towards it. Right. Now on our map here, we can move back that cube. We just have one cube here, right? We press play on that. You can notice how the second line is running before the first line runs. I'll replay that while with the cube further away so we see it. By the way, these lines highlight depending on which one that's running. See, this one will only activate once it Cosmo bumps into the cube. So even if I, swap out around these lines, this one condition is never met until Cosmo moves towards it and bumps the cube, right? So I believe, depending on what program you write, this could be a important factor to take into consideration. Essentially, just remember your command's not going to run unless this one condition is met. All right. So let's move on to the third law. We'll just delete these. Oop. So the third law essentially is describing behavior of when two win conditions are simultaneously being met. So let's say on our world here, we have two cubes, all right? And they are both in Cosmo's line of sight. Now Cosmo's line of sight is like peripheral vision, whatever. If you have a physical robot, you'll be able to see his perspective on the camera. All Cosmos come attached with a camera to simulate the important aspects of artificial intelligence through those lenses, right? Let's change one of these cube colors to red, change the other one to something like blue, right? Now they're both in this line of sight, so if we code something like how if Cosmos sees a red cube, and for it to move towards it, and we can essentially do the same. I can just copy and paste this line, but change this one to blue, right? So now if we run this program, Cosmo will simultaneously see a red cube and a blue cube, but it will move towards the red cube. Now this is when order doesn't matter, unlike this second law where it didn't. Order will matter here when two conditions are simultaneously being met. It will always go towards the first condition. So the red cube will always have Cosmo move towards it if it's above the blue, right? If we move the blue condition above, we can see that it will go towards the blue cube. So this is also very important to take into account. There are many instances where your program might have simultaneous when statements going true, and that can cause some bugs if you're not aware. So that's the third law, Calypso. Let's move on to the fourth. I will get rid of all this. So the fourth law, Calypso, deals with indentation, which is a very important aspect of your program here. To, let's say, make an indent, you just select the win condition below the main win condition you want to use. So I'll demonstrate here. Let's say we want to indent this highlighted condition here below this one. So I will go highlight in this one with my pencil. You can click or you can use your arrow keys. Press tab. Oop, that should work out. I'm sorry, enter. There we go, it should highlight yellow like this. Then once you highlight yellow with enter, remember it's enter, you can press the right arrow key and it will move it right under the above one condition. Now you can basically indent as many as you want. If I want to indent this one, I can but you know, it's no. Usually you don't need to do that, but for complex projects, there might be instances where it will be applicable. So, let's say we have a condition up here when you bumped a cube, you grab it. And then below here, you know, let's say I don't add a when condition, this will just run. So basically, if you don't add a when condition to any like statement here or any command line, the do condition is always just gonna run it instantly, right? So let's just say we can have Cosmo express happiness, and we'll just make him do it once. If you don't put that once there, he constantly expresses happiness when he bumps into the cube. Right? So we'll have a cube out here, one cube, and we need to make sure he moves towards it. So let's have that condition set. When see the cube, we move towards it, and essentially once you customize your cubes or program your Cosmo to search for cubes, this will be a pretty repetitive process. You'll get it down. So back to the map, run the program. See, he sees the cube, moves towards it. I know that was a little fast, but you saw when he bumped into the cube, he grabbed it, and then under an indent, he expressed the happiness. So what the fourth law is basically stating is any line of code that has an indent, the main part of it needs to be to run in order for the indentations to run. So anything under or anything indented under this statement right here needs to run in order for anything under here to run. So this main statement needs to run for this indented statement to run, which should make sense, right? This needs to be true in order for this to have a chance of being true. If you don't have this indented right here, I figure I should run over this right now too. Let's say I move this back out. You can just use left arrow key on that. I'll leave it here. What happens is if we run this and then this will just instantly express happiness without bumping into it. So this is a very simple example, but for some of your more complicated programs, you might want a statement to only start occurring once another condition has occurred, right? That's why indentation can be really, really helpful. Right here, you notice that we're instantly expressing happiness before we even bump into the cube, and this kind of goes back to a previous law. I believe the second law, where any condition will run if it can run, and this one, because there's no one condition to specify, it will always run no matter what, and this won't run until it bumps. So it's very important to keep in mind indentation. I think you'll utilize it a lot for all your projects. Now, finally, we should review the fifth law of Calypso here. So I'll clear my board. Oops, press delete by accident. I believe I have. We don't need to save this. I believe I have a fifth law. No, so we'll just make it. No worries. So let's clear the board here. So the fifth law, it's the most complex, I would say. It's essentially your flow of actions throughout your program. It will affect the future conditions. So how do I say it? Let's say we see a cube, right? Very basic. And then we move towards it. And then once we bump into it, when bumped into the cube, to grab it, right? Grab it. Now, this is also one we should start talking about, I guess, like, pages, I would say. Before we do that, we want to say when bumped it. Let me delete all that. When bumped it, you want to do glow. So glow is a feature or is a command that allows your cubes mainly to, I guess, glow a different color, change colors, and for a command. Like we already noticed how we can right click and change a color, and it can be glowed to a different color. Well, the glow command essentially allows us to change color. of those through our code. So glow, and we need to specify it first, remember, because we're doing a cube. It specifies the object that we're working on. So we'll glow it, the cube, and let's just say green for this instance, right? And we'll do it once. So when it bumps it, it glows it green. Now we'll say when I'm gonna make an indent here. Okay, and when bumped cube, and we could say a green cube, we can grab it. There you go. Now this condition up here essentially changed the color of our cube to allow this condition below for us to grab it. Now essentially this doesn't even need to be indented, really. We can just leave it out and it will basically have that effect still. So let's change this to none, make it less confusing. This is our code, we're gonna move towards it, we're gonna bump it, we're gonna make it glow green, change the color to green, and this statement below will then activate because it's bumping into a green cube, which we're describing here, and we'll grab it. So let's demonstrate. Finds the cube, glows it green. It goes really, really fast, but that's what essentially it did. So basically your flow of actions will accumulate depending on like how you change the properties and variables. So we changed like the property of the color of the cube to green, which allowed this condition to enable and grab it. So this is like a flow commands, right? And it will be very useful for your programs. Alrighty, so those are the 5 laws, which I would recommend you review as you make your programs. They are very important. They are the main function of your code. So I'm going to review now a very good example, in my opinion, of how I guess like all these laws can come together, or just the program that you can do with Calypso. And yeah, so let's imagine a world. We're going to need to build this world too. So let's come over here to map editor. Imagine we're on an apple farm or an apple tree farm, right? And we can have these walls here as like our field borders, or or fences to each of our apple trees. So I'll move like 3 of these out here, right? And then we can have a cube to represent our apples, right? There's like cube 1, we'll have cube 2 here, and we'll just keep 2 cubes from now to represent apples. Now we want to grab ripe apples. Alright, make sure you understand that, ripe apples, and we will describe ripe apples as apples that are red. So we will code these cubes individually to turn red at a certain point in time to represent a ripening process. Now we want to pick those ripe apples and store them. We need a storage, right? Let's consider our storage one of these markers. We'll just take the 2 circles markers as like a generic example. But you can use any of these markers. Just make sure you code it towards that marker, right? So this is our environment basically. Let's go back to the editor. Now we are on. Keep this in mind. We are on the robot character right now, and we want to be for this instance at least. So for Cosmo code, you want to let it see a cube that is red. So if it sees a red cube, now we describe a ripe apple as a red cube. So we'll just move towards it, as we have been for the fast demonstrations. And then the basic statement of saying if it bumps into a cube that is red. Now you're bumping into a cube, no matter what. At this point, when you move towards it, just this extra description of red kind of secures it to ensure that it is the correct cube you bump into, the red cube, which is what you want. Then you want to just grab it. Now you want to put an indentation below here to switch to page 2. Now you have 20 pages that you can utilize for different commands here. I will go back slowly to the first page. It's essentially a page is like another section of code that you can put into if it starts overcrowding on your first. You want to use pages because if you just crowd everything to your first page, you'll have a lot of conditions possibly intermingling together, and it's kind of hard to navigate, around your program then. And so basically, multiple pages allows more options to your program without everything getting too messy. And also due to some laws, remember the third law I believe you reviewed. If simultaneous conditions are being met, then only the first one's going to come or happen, which can definitely cause problems. But pages allows us to fix that essentially. So we'll leave this here. But what this is saying, we're just going to switch to code on page 2, which we will write a few things here in a bit. So back to page 1. Now, if we run this program right now, and let's say the red apple's not in the site, we don't want Cosmo to just stand there, right? So we can add no win condition here, and basically just always, this is gonna end up having Cosmo just, let's say, move, right? And then we can have him wander, right? I would actually go in this instance though. We can do a turn and wander. So what the turn and wander does is he'll stay in place, but he'll be turning around to look for the apples. And if it gets in his line of sight, which most likely will, Cosmo can starts to move towards it. All right. So let's move to the second page code then, which is going to be needed. So essentially, the second page is going to run after it bumps into the red cube and it grabs it. That's a very important aspect to keep in mind. It only runs after we have the red apple. Now, what page 2 is dealing with, page 2 deals with the matter effect when we have that apple in our hands. So when it sees, let's say, the 2 circles, right here. Now, remember what the 2 circles are? We designated the 2 circles as our basket, as our drop-off point for these apples. We're going to move towards it. Alright? Now, when it bumps into it, it's similar to how it bumps into, any cube or whatnot. When it bumps into the 2 circles, we just want to drop it there. So, like so. And then we want to head back to page, let's see here. Switch to page 1, so we can repeat the process of looking for another apple. Right? So why don't we try this program? Let's set these colors to red. Why don't we manually set that? Make sure everything is good here. Yes, we should be good to go. Alright. So we'll run it. And now remember about your first law, if it sees 2 simultaneous objects, it'll go to the closest one, which in this instance it was this apple right here. Now notice how we have this issue occurring. Now obviously this issue is going to occur because once we grab that red apple and we bring it back, one sec, we bring it back to the basket, okay? Goes back to page 1, we drop it off, but the apple is still red, right? And it instantly sees that red apple again. It bumps into it, which since it's already grabbing it, it's already touching it. It grabs it, and it switches to page 2. It sees the 2 circles because it's right next to it. It bumps into the 2 circles because it's touching it. It already went there. It drops it, it switches back to page 1, and it just continuously repeats the cycle, right? Now that's mainly because it continuously sees a red cube. So to fix that, we should start coding a cube. Alright. We go here to select the character and cube 1. Now, before we fix that, why don't we add, by the way, to fix that, we're just gonna change the color once we drop it off. But we can, as always, simulate the ripening process. Alright. For now, let's just keep the cubes red. How about that? But we're gonna say when it bumps into the 2 circles markers, we will glow me. Now remember, we're on the cubes. I believe I should have mentioned this, but I switched from the robot code to our cube code. They're two different things. The robot, you're coding Cosmo itself to do its action. When you're coding a cube, you're coding what the cube can do to itself. So when the cube itself is bumped into two circles, which is going to happen because Cosmo is going to carry the cube into it, we're going to glow me. Me describes the cube itself because we're the cube right now, or editing inside the cube. And we can select the color. I'll say white for clear. Meaning that it's been cleared and we've established that this apple has been stored. Let's just say it to do it once. So we notice that we're still getting that error, right? Well, that's essentially because remember that these are two different cubes. Now we coded cube 1, so we can notice how this is by the symbol. This is cube 1. But right now, Cosmo is going for cube 2 because of the first law of Calypso, where it goes where the closest object if it sees two the same. So let's just, if we put this line in cube 2, when it bumps cube 2, we can glow me weird and white. Yes, white once. So notice how we have, oh, sorry, this is supposed to be two circles. Yes, when it bumps the two circles, it'll glow me white. On cube 1, we notice it'll glow white when it bumps the two circles. And we want to do the same thing here on cube 2. So now let's run the program. Alright, so it goes back, takes it back to the basket. We drop it off. And now see that the cube turned white. Cosmo knows that cube is stored safely because of the white condition. And then we store the other cube back. And yeah, now both cubes have been stored. So did you notice how I would play it again? Cosmo was able to understand that cube is safely stored. He started searching for the other ripe apple. So also to keep in mind here, on the physical Cosmo, he'll probably need to wander a little bit more. It seems on the cloud version, he can instantly detect the other red cube or instantly see it, even if it's not in his peripheral vision. So just be aware when you're working with the physical Cosmo, he'll need to wander a bit and get his camera and sights on the cube. The other thing I want us to notice is how he navigates a path between these, barriers or fences, as we can describe them. That's also a great pathfinding feature of Cosmo, and you'll be able to work with that on your own border walls as well. So let's get back to, I guess, the apples part, the ripening process. So for now, why don't we move this condition to page. Or let's just lay it out right for now. We're gonna re-add it because this is a very important condition to have. If we don't have this condition, remember it's gonna constantly turn red and Cosmo will only see a red cube. So let's remove that. And let's say let's add a timer feature. First we're gonna go here. We're gonna change the color to white, or actually no color at all for both these cubes. Then we're gonna, because remember these are just to pretend these are little sprouts of apple trees. All right. So go back here, add a timer right here, and we'll just say 5 seconds. All right. We're gonna glow, change the color of me, the cube, to yellow. Right. So apples generally ripen to yellow first, and then they'll turn red. We can just do that into our program. Now we want to use the pages feature for this, so why don't we switch to page 2 for the cube. We did this for our Cosmo robot too, the main robot code. So while on page 2, we want to have the condition when C me yellow, right? If it sees itself as yellow, which it will, guaranteed it will, because the only feature it's gonna be able to switch to page 2 is after it loads itself as yellow. changes itself to yellow. So if we have that locked in, we're gonna move that and that a line, and we'll add in our timer feature. So the timer feature, basically we put in one statement, the do stuff is only gonna happen once the timer is up, which is 5 seconds here in this instance. We're gonna say glow me red. So this essentially allows our apple to fully ripen. Now we have a red apple for Cosmo to detect, which is the ripe apples, right? Now we want to add that feature we had before where it bumps into the storage bin or 2 circles, and we want to make sure we glow it a different color, such as white, you know, to represent that this apple has been stored, so we're not constantly picking it up and dropping it. So this is now, I would say, a pretty decent program. We just gotta make sure we do the same though for cube 1. We made that. Didn't want to run that. Remember, we gotta not confuse the different cubes and make sure you program it for each cube. So we had when timer is 5 seconds. We glowed me yellow, and then we swapped to page 2. Switch to page 2, right? And then on the second page, we made ourselves see ourselves as the color yellow, and we had our timer feature to 5 seconds, and we'll make sure we can ripen ourselves glow red. And we also want for this apple to make sure we have that feature of when it bumps into the storage bin, it glows itself as white, the color to represent that it's been stored and it's clear. Right? So let's take this all down and run from that. So notice how it causes wandering. You remember on the first feature we had him just turn and wander. He sees a red cube, which now he has. And we can move to go get it and move it back to storage. And once he drops it off, it should turn white. Now he will search for the other one, which he has found. And once he sees the direct line, it basically represents that he found the cube and he's going for it. He's navigating a path to get back. There you go. And now he continuously wanders, though there are no apples left, so his job is done. We can, we can change this program up a little bit too, Let's say for one of the apples, it takes 10 seconds to ripen instead of just 5. And for the map, we can make the course a little, less symmetrical, right? Put these around different places. And you can change how a few things run. So let's run the program there again. So, see this one's ripening a little faster than the other one. Well, it finds that, and we will pick it up, navigate a path, back to storage bin. This is our little apple tree picking Cosmo. And right here, see how we navigate another path? The Cosmo detects the best path we can take, and it determines a route to get to the apple and to bring it back. I'll let him finish here. Perfect. Alright. So, that utilizes a lot of indentations and various rules that enable our program to successfully work. So let's go back and take a look at the robot. And this is our Cosmo, seeing the red cube, bumping into the red cube, grabbing it. You'll be using, a lot of these types of presets throughout your programs. So that should be it for this workshop. So I believe a lot of these navigational features and skills of Cosmo will definitely be helpful to you in your projects. I will see and hope in getting you a PDF or a PDF summary of what we went for today. And that should detail our laws and plus the project and its features. So hopefully that'll help. Feel free to contact me or any other instructors around here if you have any questions, and we'll do our best to help out. Thank you for joining in.